In this video, we are going to learn how to apply derivatives to analyze the functions. We learn the steps to find intervals of increase and decrease for a given function, the steps to find local maxima minima, and the steps to find global maxima minima as well. Here I have presented all the steps for the three procedures in a tabular form so that it becomes easy for you to memorize them, and you can also differentiate between them at the same time. First step is same to check all the three parameters, whether you need to find intervals of increase or decrease, whether you need to find relative maxima minima, or you need to find absolute maxima minima. Step 1 is same for all the three procedures. For that, we just find the first derivative, then set the first derivative equals to 0 and solve for x. Then you would get the critical points. And we need critical points for all three of them. For the second step, using the critical points, we find the intervals on a number line. Then we test each interval one by one by plugging in some testing points from each interval into the derivative. We plug in the testing points into derivative and then note down the signs of derivative on those intervals. This second step is same whether you need to find intervals of increase or decrease, or you need to find local maxima minima. But if you need to find global maxima minima, then you don't use this step. We don't need to find the intervals for global maxima minima. What we do, we just plug in the critical points and the endpoints of given interval into the original function. So this would be the second step for global maxima minima. Then we write the conclusion for step 3. The function would be increasing if the derivative is positive on some interval, and the function would be decreasing if the derivative is negative. For relative maxima minima, if the derivative sign changes from positive to negative, then that point would be maxima. If the derivative changes from negative to positive, then that critical point would be relative minima. For global maxima minima, we look at the function values at the critical points and the endpoints as well. The largest value out of them would be the absolute maxima, and the smallest value out of those all values would be the absolute minima. Now let's work on an example to understand the steps better, how to get the three different parameters for the same function. Here is the given function. So first we find the derivative. Set the first derivative equals to 0 and solve this equation for x. Here we can factor out 4x, then set each factor equals to 0, and here we get the three critical points. So we get the three critical points, -1, 0 and 1. Next we draw a number line from negative infinity to infinity, and using three critical points, we get the three intervals on this, -1, 0, 1. So the first interval is negative infinity to -1, second interval from -1 to 0, the next one is from 0 to 1, and the next one is 1 to infinity. So we have 4 intervals. Now we are going to test each interval one by one. To check the first interval from negative infinity to -1, we pick -2 as the testing point and plug in that point into the first derivative. We get the negative result for this interval, so we put a negative sign on this interval. For the next interval, -1 to 0, we can choose -0.5 as the testing point, plug in that, and we get 1.5, the positive value. Same way we can check the next interval 0 to 1. For that we can pick 0.5, positive 0.5. and plug in that into the first derivative, we get -1.5. So we get a negative sign on this interval. Then for the last interval, we can check 2. We got a positive value. So the derivative is positive on this interval. We know that function would be decreasing when the derivative is negative, and the function would be increasing if the derivative is positive. We see that the derivative is negative from negative infinity to -1 and 0 to 1. That means the function would be decreasing on these two intervals. So we can write the intervals of increase and decrease from here. So the decreasing intervals are negative infinity to -1 and 0 to 1. And the intervals of increase are -1 to 0, 1 to infinity. So here we got the increasing and decreasing intervals. Next, we are going to find local maxima and minima. For that, both the two steps would be exactly same. For the first step, we find the critical points using same way, and we would get the same critical points for the given function x to the 4 minus 2x square. The second step would be same. Using the critical points, we get the intervals on a number line and then test each interval one by one using the testing points from those intervals and plug them into the first derivative like we did here. We are going to get the same result and exactly the same signs of first derivative on those intervals, and then based on those signs of first derivative we can find the conclusion for local maxima and minima. Just have a look at the rules to find local maxima and minima. So there is a local maxima or relative maxima when the derivative changes from positive to negative, and minima when it changes from negative to positive. So here we see that the derivative is changing from negative to positive at -1, and it's again changing from negative to positive at 1. That means these are going to be the points of minima. When the derivative changes from positive to negative, that point would be the maxima, local maximum point. So here at 0, the derivative is changing from positive to negative. So this would be the point of local maxima. So we can write the conclusion here. So the given function has a relative maxima at x equals 0 and it has relative minima at x equals -1 and 1. Next, we are going to find global maxima and minima for the same function. For that, first step would be same. We got the same critical points using the same process. Critical points are -1, 0, 1. The second step would be different. We don't need to check the intervals. We don't need number line. So what we do, we just plug in the critical points and the endpoints into the given function. Here we have the same critical points -1, 0 and 1. So we are going to plug in those critical points into the original function, as well as we plug in those endpoints -2 and 2 into the original function. Plug in them one by one in increasing order. First we plug in -2. At -2 we got the function value as 8. Then we find the function value at -1. Then we find the value at 0 and then at 1. At last we find the function value at the rightmost endpoint. That gives us the same value 8 as we got on -2. So we got the function value as 8 when x is -2, -1 at -1, 0 at 0 and -1 at 1, and then 8 at 2. Now we find out the maximum, the largest value out of them. Out of all these values, 8 is the largest one. So this is going to be the global maxima or absolute maxima. So this function has global maxima at -2 and 2. Here you can note down that a function may have global maxima or minima at more than one point. Here you can see that this function has global maxima at 2 points, at -2 as well as at 2. Also, this function has the smallest value as -1 at 2 places, -1 and 1. So this function is going to have global minima again at 2 points, -1 and 1. So we can write the conclusion over here. So here we see that the steps to find intervals of increase and decrease or relative maxima and minima are exactly same. There is a difference between writing the conclusion, how to get the conclusion. That way is different. The intervals on which derivative is positive are the intervals of increase, and the intervals on which derivative is negative are the intervals of decrease. And when the derivative changes from positive to negative, that is relative maxima, and when the derivative changes from negative to positive, that is relative minima. So this is how we find increasing decreasing intervals and relative maxima minima. To find absolute maxima minima, the first step is same as the other ones. We get the critical points, but for the second step We just plug in the critical points and the endpoints into the original function. The largest value out of them would be the global maxima, and the smallest value out of them would be the global minima. So finding global maxima and minima is very easy. It's easier and shorter process when you are given a closed interval. I hope you find this video helpful. See you in the next video. Till then, take care. Bye bye.